Hello and welcome back. Today I have some things here from my friend from Italy, Andrea. It is also a viewer of my channel and a fellow hen. It is I3APR, and he gave me to borrow GPSDO and distribution amplifier, an antenna splitter and a normal amplifier. And it's all from Europe because he had so many problems ordering in China, and then it was broken. He just had a lot of bad luck. So he decided, I'm going to stop buying in China. I tried to find in Europe, and he did find it. Here is a GPSDO, and it's from the DXpatrol. It's from Portugal, so it's safe to order within Europe. It's possible. And we're going to play a little bit with that. And also, and that looks really nice, I must say, it's a distribution amplifier, and it has some really nice filtering. I think they even say the harmonics are filtered down to 60 dB, so they 60 dB and below, so they do a really nice job, and it looks all shiny and gold. And this is from Greece, and it's from SV1AFN.com. It's a ham, as you noticed, and yeah, he makes a lot of nice things, like even this little nice boxes. I will zoom in a bit, and yeah, let's see how it works, because I usually have all this Chinese stuff, and I must say, price-wise, especially now we need to pay tax from China, the price difference is not that big anymore. So it has become a bit more fair for European sellers. So, but yeah, what about the quality? Let's see. Okay, we can have a quick look at the website. I'm not affiliated with DXpatrol or SV1AFN, but I just like to show you what is available. And well, they have a lot of kits, and well, the GPS that we have looks a lot like this one. So they have SDR, they have some wired antennas, balloons, but I will just go to the kits because that's what I have here. And they have some ground station up converters. It seems they know their stuff in GPSDO land. And this is what we have. And you can download the manual here. There's a little OLED display, and 160 euros. That is more or less what I pay for my GPSDO also. So in that sense they are equally matched, and it is in Europe. So then we have the other guys here from Greece. It's a DUI guy, and also, I'm not affiliated with this, but I like to show what I have. And yeah, he's just, you can see he's a ham, he is into everything RF. And let's focus on the GPS here. He also does have a GPSDO IC, and also with multiple outputs, so that's convenient. Here we have the low pass, and we have somewhere also the splitter. Here is the splitter, and it also has a little amplifier, this splitter, so what you lose by passing through it you will win again with the amplifier. So it's really smart. This is the distribution amplifier. That one is a little bit more expensive than my Chinese one, but this one also looks black and gold. So it is probably properly made. Here you can see all the filtering, what is done. I think it's partly square wave and partly sine. Here you see all the suppression of the harmonics right here. Nothing. We can do a test on that. And I think this looks like some proper quality. So let's test this in practice. So here we have it all. Let's start with GPS. Now the GPS has a little display. You power it from the front, and you can see it's a 10 MHz reference, so it probably does what we expect it to do. You put your antenna, and well, it has the, I think this is the 1 ppm, and it has then also 3 exports, which is great. 10 megahertz and 7 dBm, so it's quite loud. But that is okay. After this, you probably just put it maybe through your distribution amplifier, or if you only have 3 devices, then all this is enough. So let's have a look how that works. And the distribution amplifier has a lot of filtering. We're gonna open that up and have a look. And well, we can maybe compare it with this one. It does have different ports, but the Chinese one here you can also order with SMAs. But I didn't, because I have those BNCs everywhere. I use this one, and this is not a trigger amplifier. This is really a 10 MHz distribution. So this one has 10 MHz band pass filters also. This one is more expensive than the normal trigger amplifiers. But so it's fair to compare because both have filters. That's band pass filters that should filter out all the harmonics. So that's a nice compare. We can compare these, but yeah, I can just see if the frequency is correct. It is not fair to compare how fast the cold start is, because this one was switched off in Italy and I'm switching it on here, and this one has been switched on and off here already. So I'm not going to look at that, but we can have a look at the signal. And yeah, and here we have some other nice things. This is an antenna splitter. So you can connect 4 of your GPS receivers to one GPS antenna, and that's actually useful for me because I have 3 GPS receivers. And now with this borrowed one, it's 4. So we can try in practice how this works. And if the signal is not loud enough, because your antenna you cannot put in an ideal position, then maybe this will work. This is a low noise amplifier, and I think this is all it has here a power connector, but I think it's all powered from your GPS module. So I have the 3 GPSs here, but I have only one antenna, and it's poorly also. So I try first without the amplifier, but I can immediately try to do the splitter. Well, I zoom in and we try to connect, but if it turns out it takes a really long while before it has its fix, then I try to connect them through the splitter, and then they can all 3 try to get the fix at the same time. So let's get the DXpatrol. Antenna is connected. We have a few outputs. We check later what actually comes out. I will get this one on already. It is starting. Well, it's waiting for GPX, but you have some information. I think the number of satellites, probably UTC time, yes, UTC. And it's acquiring position. Well, as I mentioned before, I just throw the antenna out of the window, so it doesn't have a perfect view, but it now already has 6 satellites. So I think I connect the splitter. One receiver is giving the power, so I will use my devices for that. Then if it breaks, it is not a real problem. So let me see, RX1 with DC voltage, yes. Do I have shorter ones? Because this is really long. Oh wait. Okay, I did find some smaller ones. So let me just connect that here. Then this is my receiver 1 that provides the power. The rest is all isolated. This is the antenna itself. Okay, perfect. Then this is the second receiver. That could be this one. And then we get a third receiver. It can be this one. So it already has a lock, by the way. That is very fast. Perfect. But let's see with the so let me see the antenna. Okay, then the receiver. So we have all three receivers connected. Let's see how that works. So we need to power first this one, because this one provides power for the whole splitter. So that will be switching on. It is powered. Okay. Then we can power this one. And we power the other one also. Well, you see it has a reception here. GPS plus GLONASS, but doesn't have a fix, but the reception is here. Let's see what this one will do. They are now all locked. You can see a slight difference here, but that's also because the oscillator is still heating a little bit, trying to stabilize. I see the current dropped already a little bit, so I think it is now good. But now it needs to calculate. No, that's what's happening. And you see the seconds here are exactly the same. And now also in this one took the longest to have a lock. But maybe it is also just waiting until it is very close to the 10, like here. This is already below the hertzes, like here. This one is already spot on. And this is still stabilizing. They both use a different oscillator, and I think this one is again another oscillator. We can have a look at that too. And let's see how clean is the signal. Let's see on the frequency counter. I'm using my port A, so frequency A. I must say this little one gets you really hot, and it is a little bit hot here in the room. Probably 25 or something, but this is really, maybe because it is that small, it has not much room to dissipate its heat. And maybe in a warmer country, maybe in Italy even, this will get really hot. And I'm exactly giving it 12 volts, so that's not a problem. Let me just probe how hot it is. Okay, in the room it is a little bit hot, but if I probe on 35, this is Celsius. How much is this? 36, also because this one is of course heating it. Yeah, this one is already 43. So because of its size, it's getting really hot. Maybe it's heating each other, but I don't feel these are that hot, so it's really heating itself. But let's not put it on top of each other. This one really is the hottest. It's also the color black maybe, but it should also dissipate better. So anyways, let's see on the frequency counter what will happen there. So first, if I do the little one right here, and my frequency counter is running on my other GPSDO right there in the top. So let's see how this all compares. Well, these two GPSDO agree a lot. Maybe if I do even 2 seconds, look at this. So my GPSDO on the top agrees a lot with this one here. That is good to know. I was a little bit, if I put 20 seconds, we need to wait a little bit longer, but this is always scary if you have multiple GPSDOs. Which one will give the correct value? Well, we wait a little bit more, but then I will put it back to 2 seconds because we will get the idea. These two are good. Yeah, look at that. That is good, and we are here below the hertzes because now we are in full, and now we are in, yeah. Okay, so this one is okay. That was this one. Then we have the black one right here. It's moving a little bit more, but still it agrees. That is nice. That is nice. Now let's see our nice European one from Portugal. How is this one doing? As you see, it's super loud, the signal. Maybe I can put the attenuator. Also spot on, so yeah, perfect, nothing wrong. Okay, now I'm trying to find another camera position, and I hope I'm not gonna block the side myself, to put it on the spectrum analyzer right here. And I will make some print screens. Let me add my stick in there. And first we do again the silver. And I think this one only has sine wave out. Yes, it has. Let's auto tune it. And we have a nice signal. Let's do it a little bit wider, because then we can see if there are. No, perfectly. Oh, I didn't know. Oh, I have touchscreen, of course. Cool. Some measurements. Harmonics. We can do a print of this. Okay, let's get the black one. That is an older GPSDO, and this one only has square wave out. And the square wave usually have indeed all these harmonics. That doesn't need to be a problem because you can use bandpass filters, and I have the bandpass filter in my distribution amplifier. But still, let's just record this output. Yeah, okay. And then let's have a look at this machine. And this one have both outputs. I have here sine waves and squares. So probably with the sine, we see exactly that we saw with the silver one. I will save this. But when I probably put it on the square wave, we will have the same effect with all the harmonics. Yes, we have. That is normal. That is just because of the type of the wave. Well, I have a little bandpass filter right here, and I can show you if you keep an eye here on the spectrum analyzer, I will use the same port. I just put my bandpass filter in between, and then connect that to the spectrum analyzer, and then you will see exactly the same nice clean signal. And that is what I usually do in this distribution amplifier, and in this one, that even if you put a square in, they just clean it up. And I can show you, it also changes from being a square into being a sign. You see a nice sign, and if I use the same port but without the bandpass, here we have the square. So let's have a look at the oscillator. I think, if I remember correctly, this was a Vector. No, it is not. This is an unknown brand, but you can see it's kind of big. And that one is getting hot. But that is normal. 50 degrees. But because this is quite big, it can dissipate this heat, and you see immediately that it changes because I opened it up. And this one is a quality. Here we have a tremble. And I don't know how hot that one is. That one is less hot. And these are all second-hand from old phone towers, but it doesn't matter because they get disciplined by the GPS. And this one should be, yeah, here we go. That's a smaller one. This is a CTI. Also 10 megahertz. And it's also around 60. Now it's dropping immediately because we open it. But yeah, it's also around 60. And this is a lot smaller, so it's heating the whole package. I'm not, yeah, it's a pity it's getting so hot. And one thing I'm missing, that's serial output, because this one and this one have serial output, and if you like to look at NMEA data, that is great. And also if you have the U-blocks, you can switch on several standards. Like here I put the GLONASS, here only GPS, but I switched on also GLONASS and this one and Galileo, because that is possible on these U-blocks receivers. And this one I'm not so sure. I do see some pins, but I don't know which one is the serial. Yeah, this could be also a U-box. But yeah, I don't know how to do that because there is no serial connector. Yeah, and I must say the splitter works really, really well. It's completely cold as it can be in this room. Yeah, 30. Doesn't even feel like hot, but if I take some other point, it's just ambient. So that is really cool. And it doesn't need external power, it's just powered from the receiver. One of the receivers, of course, otherwise it goes wrong. I like it, and they all have full reception. Just full reception. This one says it even has 9 satellites, but I'm here on the roof now, so I can actually see only half of the satellites. So we can try the amplifier, but this is already full scale, so I don't think it will make any sense. Okay, I've put it now the amplifier in between, but the signal is less good, probably because it is already loud here. And I put it first through the antenna and then to the splitter. And they both use different lights. This one uses a white one, this a red one. Yeah, I don't know why it's not the same color. Yes, without the amplifier it is better. So I don't know, I connected it the right way. Okay, what I like to do now is get a dirty square wave here from my square wave distribution. It's a trigger amplifier. It's not necessarily for 10 MHz. I want to put it through this one into this one. Then we have a look here on the scope and on the spectrum analyzer right there. And let's just set that up. So we need a little one here. Yes, yep. So we have our 50 ohms here. Here we have high impedance, that's okay. And I want one here. I want the two longer. One here. On the input here. On one of the inputs. Here, sync output. This is input. External source, so it also has an internal source apparently. That is good. Okay, then I need the cable for the exit. First have a look at this one. That goes here. Now, then I need another. There are two outputs here. There are sine waves and LVCMOS outputs. Let's also get the sine then first. Okay. That's why I like better the BNCs, because this is... Come, yeah. I will connect both already. Let me get another one. 12 volts here. No, doesn't go. No, they use a bigger pin. That is a pity. Okay, well, I managed to power it in a different way, but that would be... I don't understand why they didn't use the standard DC plug. So now I'm powering it externally. I just don't have that. So here we have now on the oscilloscope we have the silver one, and as you can see it looks nice. No harmonics at all clean. And let me, yeah. All clean. And let's do the same with the sine wave with this one. Does it look just as clean? Yeah, it seems a little bit lower than this one, but it is clean, nothing wrong with it. Then we also have the square outputs, and I'm suspecting that it is, yes, it is indeed. That is what you get with squares. Well, that works all as expected. Both are filtering, so when you pick the sine wave outputs, they have these little bandpass filters, just like what I showed you before. So that's all. The only thing is here you have 5 square waves, which are less clean, and 5 sine waves. Well, here you have 8 clean ones. So it depends what you want. But usually this is clean enough anyway, because I'm using even trigger amplifiers, which do also not have any proper filtering. And then you have the same as on your squares here. And I did not have any devices having a problem with that. As you could see, everything was exactly 10. So no problems there. I want to open it up. And why am I doing that? Because they both have also an internal oscillator. So when the GPSDO doesn't give you any signal, these devices can give you the 10 MHz as your standard. But you need to realize you can still connect all your devices with this, and then at least all the devices agree. But then you start living on an island, so your 10 is maybe not necessarily exactly 10 because you're not using the GPS. But of course it's better than nothing in some comparisons. It doesn't matter too much. But if you do have a GPSDO, then you can adjust these clocks to set them good. And then when somehow, if you have a failure in your GPS, you just switch them over to your internal oscillator, and then you still have a near good signal. You need to be a bit careful here because this was a bit tricky. This one, by the way, switches. The Chinese one switches over automatically. If it notices there is nothing on the input, it switches over on the other one. But it does mean that the oscillator is always running, so it will use a little bit more power. But I made the modification also for my amplifier there. I just switched it off. So now I wonder what probably needs to slide instead of pulling, so we have a look at that later. I wonder what is inside. Okay, they both have been on for I think 10 minutes, so this one I manually need to switch over, so I put it to external. How precise is this 10 MHz in this one? Well, it's half a hertz off, so that is not bad. I have something else here, what I don't understand. Output disable. Manual source. Oh, you can switch all the outputs off. Okay. Yeah. Okay, not bad. How much? What is this one doing? So I can adjust it to make it better. This one is actually spot on, my silver one. But I probably already adjusted it once. So this is my backup, and you can see it is really useful to have one. So I'm now comparing with my frequency counter that is connected to my active GPSDO. I'm comparing it against purely my distribution amplifier with its own OCXO, and as you can see it is useful because it is almost just as good. So I can help my friend and adjust this one a little bit to get it correct. So now I opened it. This is my Chinese one. It has again these famous oscillators. This time it's a CTS, exactly 10 MHz, and well, it showed it was exactly this one. I am not sure. I do like the filtering that they did. They really adjust everything with these little coils. And but I don't see necessarily where the 10 MHz comes from. Maybe it is this little there, this little block. So let me adjust this a little bit. So it is actually 10. I see here a multi-turn, so that is probably it. I'll try not to put my hands in between, and let me get the frequency counter also. Okay, let me adjust it a bit. I see here a multi-turn, and this is probably it. But I want to do that last bit too. But now I'm in the screen with my hand. I think we improved it. I will keep it like this because it's a really small oscillator, and also when I'm turning it doesn't seem that it is really, yeah, but this is great. This is better already. So that was nice comparison. We can see what you can buy in China, what you can buy in Europe. Well, now it is already stabilizing a lot more, so my friend will be happy, I think. Yeah, if I compare the two distribution amplifier, I can't really say which one is better. They're just a little bit different, and both the filtering looks very nice on the filtered ports. This one has 10 ports in total, 5 in square and 5 in sine. This one only has 8, but they are all sine. So it depends how clean you want your signal to be, but I already know from practice using this. Instead of this 10 MHz distribution amplifier, I have here trigger amplifiers, and the device will understand the signal, so that was never a problem. Both have internal oscillators. This one is kind of just a little crystal oscillator, while this one is a proper OCXO, so I like that a little bit better. This one has BNC, this one is SMA, but you can also buy this one in SMA. Yeah. Which one looks better? I think that is personal. I like the black is also nice, but I absolutely don't like that the DC plug is just different than all my other devices. So that's it, but it looks like some proper quality. So you can just pick, I think, which one is easier for you where to buy. Also, you need to keep in mind the warranty and maybe import. So if you live in Europe, it could be a very nice choice to pick this one. And with the GPSDO, this one is very nice and small. I will get both the black ones. They are very nice and small. It does get really hot, and I think if you live in an even hotter environment than I live here, today is now around 30 degrees in my room in Celsius, and if it gets 40, I think this one will really burn. And but I do like that you see the number of satellites that it can see in the display, and yeah, the power plug in the front. Yeah, maybe would have been better in the back, but the back is already full. Also, I like it as 4 outputs instead of 1. That is nice. Both oscillators are good. I like from the Chinese one that it's a little bit bigger. It gets less hot. It only has 1 output. You have them or in a square or in a sine, but in the end it doesn't matter. If you use a distribution amplifier like this, you always end up with a proper sine. I like here the serial port, because then you can play a little bit with the NMEA data, and if it is a blocks receiver, U-blocks, and I think this one was also a U-blocks, I can have a look in the microscope. I like you can change and switch on and off certain things. And this one is now, it says GPS, but there actually is 3 standards. And this one, I just don't know. It is how you get it, and I cannot check it either. Because there is no serial port. Because it would have been nice to check. And if it is a U-blocks and it is the generation 8 or 9, I think, 7 or 8, then you should be able to switch on some more things, which is nice. But available in Europe, all safe. That's also a good choice. Well, I quickly opened it up again. and it is in Neo 7, so that makes me think yes, it is a U-Blocks, but it is a Generation 7, and yeah, Generation 7, I think you could read from it, but you could not necessarily write to it, so it is an older one. If you have an 8 or a 9, you can have those extra options. So that are a few things that are also available in Europe. So if you're not comfortable buying in China, this is absolutely one of your choices, could be one of your choices, because it does work properly. And yeah, the quality also seems very good. Andrea, thank you for letting me borrow this, and I could play with it a little bit. And you, thank you for watching, and I hope to see you next time.